So in this video, what we want to look at is what we call the Cartesian plane. Many times students are not able to understand what the Cartesian plane is. How do we read anything that is on the Cartesian plane and the whole understanding of it? Sometimes it is not being connected with the students. And so today we want to look at how do we actually construct it, how do we actually put it together, and how do we read things from the Cartesian plane. Cartesian plane can also be looked at where statistics is concerned, data presentation, a line graph, a histogram, a bar graph, a comparative graph, and all those kind of data presentation. The Cartesian plane is very useful for that whole task and performance and so on. So we want to look at it. How does it look? How is it read from the standpoint of points, or what we call coordinates, and so on. So we just want to look at the basic of it, the very basic, and just to get the understanding clear. So the first thing, how do we construct a Cartesian plane? So the first thing we're going to do is to draw the axis, that's what we call the horizontal axis. It's also now called the x-axis. And so I'll start from here and I'll go here. Well, I don't want to go way up to the end of the screen, so I'm going to put up an arrow there that indicates that this line continues infinitely. And so let us use another color for this. So I'm going to use a red for this, and I want to go straight up. So if you look at it, this line that which I drew first is what we call the x-axis. The x-axis, or it is now what we call the horizontal axis, or the horizontal line or axis. And the vertical one that is in red is what we call the y-axis. And so this is what a part of the Cartesian plane looks like. And so if we should label this Cartesian plane, the first thing that you look at is the origin, where the two lines meet. Where the two lines meet, it is called the origin or the reference point. That's where you start. If you're actually traveling on the x-axis or the y-axis, you will actually make your first step away from this point to where you're going. And so we'll look at that in the future. So if I'm going to label the x-axis and the y-axis, then I'll have to leave it like this. So if this here is 0, this point right here is 0, if here is 0, then the immediate step to the right is a 1. So a 1, this will be 2, 3, 4, 5, 6, I could say 7. And this continues in counting. I will do the same thing for the y-axis. 1, 2, 3. It continues, but my y-axis is very short. And so if we were to put what we call a point, or what we call a Cartesian, what's called a coordinate. And so you could actually interchangeably refer to them in whatever name or title you want to give them using these names. There are other names for this kind of thing, but since we're dealing with the Cartesian plane, the Cartesian system of coordinates, we'll be using the word coordinates. And so a coordinate is just a point that is located on the Cartesian plane, and a point has two representation of units. It has units on the x-axis and units on the y-axis. I'm going to look at that. So if I should put a point anywhere on the graph, on the Cartesian plane, let me just move this from over here and put it somewhere else, like say put it there, y-axis. So if I should put a point right here, and I should give it a name, I can give it a letter, a name by a letter. I call it point A. If I should put that point right there, now this point takes on 2 units. We call these numbers units, units, units. These are called units. So this point will take on 2 units. Units from the x-axis and units from the y-axis. Now the unit that it takes is actually on the x-axis is the number 3. And so you can actually look straight across to the left. You're seeing 2 on the y-axis. But this point starts from 0. It starts from here. It starts from here. It's where it starts from. And then it makes its steps. It makes its steps. And then it makes 1, 2, 3 steps out on the horizontal. And then when it goes up, it starts from here, which anywhere once you would have made your steps from the reference point or from the 0 on the x-axis, anywhere you stop. When you stop, if you're going to go vertical, then you right there is actually 0 on the x, on the y. And so when you make your first step, you make 1 step up on the y-axis. And if you continue, you make 2 steps up on the y-axis. And so this point moves 3 to the left, to the right, and 2 upwards. And that's just simply what we call a coordinate, or you locate a coordinate on a Cartesian plane. But this is not the entire Cartesian plane. This is just a part of it. This is just like 50% of it. And so we're going to finish the other 50. So that's just simply what is, that's just simple, very simple. And so what do we actually continue with the Cartesian plane construction? So if I put a point right here, we realize that we don't have any representation right here. We only have representation for 2 on the y. So what is going to happen now is that this x-axis continues, and it even continues with that arrow. And so if I am on a number line, like this, if you realize, if I should pass 0, I am actually going down negative. And so this is the same concept when you're actually doing, that's the same concept we actually going to demonstrate. When you pass that 0 on the x-axis, you're going down on the x-axis, which is a negative. So this is also the x-axis. And so we just give it the letter x to represent x. So you don't necessarily have to write out x-axis. You could just put x, you could just put y for the x-axis and the y-axis. And so the numbers that are here will be negatives on the x-axis. And so if I should put a point right here, then the point or a coordinate, what we realize is that this point has coordinates of 2 and 3, but the thing is that we need to know how does a coordinate look in the general form, and which unit should always come first in the representation. Well, a coordinate is actually, look, the general form of a coordinate is this. Now the first unit must be written, which is the x-axis, which is the x-axis representation of the unit. So whenever we are writing our coordinates for a point, we must have an open bracket and we put the x coordinate first. We put the comma, there's a comma after, and then we put the y point, the y unit after. So if we were to look at this Cartesian plane, look at the point, look where the point is corresponding on the x-axis and the y-axis, then the first unit that we will write is the unit -3. And then we look, then this is actually saying it is corresponding to 2. And so this will, and if I should give this a name, so this is name, this will be the coordinate, and so that's how we actually represent it. What if I should put a point right here? Now this point would actually only have just only representation on the negative x-axis, and so this y-axis continues, and this is like basically all of the Cartesian plane, where you have the x-axis and the y-axis. The x-axis goes horizontally while the y-axis goes vertically, and if you realize they intersect at a point, and where the two lines meet, that's where 0 is. That's you can see. If you should move on the Cartesian plane to the left, which is a positive, you realize that after 0 you actually go to 1. 1 is the immediate number to the right after 0, and it continues. If you're going to the left, -1 is the immediate number to the left after 0. If you're on the y-axis and you're going up, you realize that 1 is the immediate number after 0 going up, and so you can actually see the concept coming out of labeling it and understanding it, what number should go there and so on. And so if you should look at this point, that's called it P. Now what would be the coordinates of P? And if you look at the coordinates of P, the first thing that we'll write is P and then write at -2 on the x, which is this one, -2 on the y, which is that one. And so if you were to actually move from the origin, you'd actually move 1, 2 on the x, 1, 2 down on the y. So if you should even look at and observe it, anytime you move in this direction on the x-axis, your steps are increasing. Each time that you go this way, your steps are decreasing. And so whenever you go up, or let's say go right, your steps should be positive. You're adding more steps to your number. And if you're going this way, you're actually decreasing from where you were. Because if you were at 2 and you move 1 step going down, what you actually did, you subtracted 1 step from where you were. So if you have 2 things and you actually end up with 1, that simply means you have subtracted 1 from your original number on where you were on the Cartesian plane. And so if you were moving on the y-axis, you do the same. If you realize, going up and look at going up, once you go up, your steps are increasing. And if you actually come down, go anywhere vertically, if you are here at 1, you go up, you simply realize that you've moved from 1, you have added 1 more step to where you were at the origin, and then you actually gain 1 more step. And if you were at say you were at 1 and you go down, that simply means you were at 1 and you ended up at 0. So you're actually decreasing. It doesn't matter where you are. Even if you were over here and you go down, you're moving from 2, you're going down to 1, 0. So once you go down on the y-axis, your steps are decreasing. And if you're going up, your steps are increasing. If you're on the horizontal axis and you're going this direction, your steps are increasing. And if you're going left, your steps are decreasing. And so that's just a simple understanding, a simply way of understanding, very simple way of understanding, very simple way. So let us look at some more things as it relates to the Cartesian plane. Now we need to understand that this Cartesian plane has what we call quadrants. And the Cartesian plane has 4 quadrants. And let's look at these quadrants. So let me Just erase these for a while. Right, so these are called quadrants. Now the first quadrant, remember the quadrant, start with a Q, quadrants. Now you know that this word is actually coming from what like a quarter of 360. Because if you look at this, each quadrant is that it is like a 90-degree. If you look at it, and if you have 4 90s, that gives you 360. But let's not look at the quadrant. So this quadrant is actually the first quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. And so the Cartesian plane has 4 quadrants. Not every Cartesian plane that you might draw will have 4 quadrants, because some Cartesian plane you don't need negatives. If you have coordinates and the coordinates do not have negatives if you're not representing any negatives, well, you don't need any negatives. But you won't be penalized if you even put negatives there when you don't need them. So it is no big deal. But originally and finally, the Cartesian plane has 4 quadrants. And so if you should just simply observe, if you put your point here, you realize that your coordinates will be both an x and the y-axis will be positive. And as you look at it, it is 3 on the x and 1 on the y, positive values. If you put your coordinates over here, you realize that only the x-axis will be negative. The y-axis will be positive. The y-coordinates will be positive, and the x-coordinate will be negative. If you put your point here, by simply looking at it, you know that both coordinates will be negative. And if you put your point here, you know that only the y-axis will be negative, while the x-axis will be positive. And so that's basically it. Cartesian plane, putting a point on the graph and all of that. That's basically it. Very, very simple. Very, very simple. X and y axis. Remember that the positive is on the left on the x-axis, and the positives are on the y going up. And once you pass 0 on the x-axis, you're going down to the negative, and that's telling you that your steps are decreasing. Even if you were right here, you're going up, your steps are increasing. Anyway, if you are located anywhere on the Cartesian plane, if you're going left, you're increasing. If you're going right, you're decreasing. On the Cartesian plane, if you're going up, you're increasing on the y-axis. If you're going down, you're decreasing on the y-axis. And so that's simply it. And even what if we had a coordinate? Let's say we had a coordinate P, and you say 2 and negative 3. Well, positive 2, negative 3. Where would we actually locate this coordinate? Where would we actually locate this coordinate? Well, we would actually locate this coordinate at let's get some more space on this. So I'll put it right. So it says positive 3 on the x-axis, because remember that the x-axis is the unit that actually is written first. It is written first. So this one it represents the x, this represents the y. And so we write for the x. So we move 1, 2. Let's use a different color. We move 1, 2, 3 on the x. And it says negative 3 on the y, so we are going down on the negative. 1, 2, 3. And so our point will be right here. That will be point P. Let's look at it again. Let's look at another one, no matter of fact. So if I should change my coordinates, and I should say positive, I should say negative 2, 1. So we actually move from the origin, we move So this is the x, this is the y. From the origin, start at the origin, and we move 1, 2 on the x-axis, and it says positive 1 on the y, so we go up. And so our point will be right here, point P. That's simply it. And so that is just basically it. But let us look at what if we had O, we say 0 on the x and 0 on the y. How would we actually point this? Well, if you should look at this coordinate, these coordinates or this point has 0 on the x and 0 on the y. Therefore, my point will be right here. Right there. I make no movements on the x and no movements on the y. So I am located at the origin. That's where all points start, from the origin. So my point will be right there. And so what if I had 0 on the x and let's say 2 on the 0 on the x and 2 on the y? Where would I put my point? Well, my point would be 0 here, no movements on the y, no movements on the x, sorry, no movements on the x, but it says 2 on the y, so I will go 1, 2, and so my point will be resting on the y-axis and not anywhere in the quadrants. It's just lying on the y-axis because I make no movement on the x, only on the y. So my point will be located lying at 2 on the y-axis. And so if I should interchange the coordinates and write this, how do you think this will be? How do you think we actually represent this? Well, we do the same thing. We say, okay, we're starting at this point 0. We move up. We have 0, 2 on the x, 0 on the y. So we move 1, 2 on the x. Is the y saying that we're supposed to make any move? No. So what do? We just leave it at 2 right there. No movements on the y. And that's that simple it. No movements on the y. That's simple it. No movements on the y. And so it doesn't matter if it were a negative or a positive. Always look at your values in the point, or your values of the coordinates to determine where you go from the origin on the x-axis, on the y-axis. And so that's it. That's simple it. That's simple it. So in our next video, we're going to look at how we actually point, or we can actually form triangles and rectangles, and also we're looking at vectors. Because vectors, we use a Cartesian plane to represent vectors, and so on. So this is just the introduction of everything. And so in the next video, we'll be looking at more things. And so let us recap. We call these units. These are called units. And so they could even ask you a question like, say, well, not a question, but give you an instruction and say, if you're going to consider a graph, use 2 units to represent 1 centimeter, 1 centimeter represent 2 units, and so on. So we will be looking at that in another video. So we look at units, we look at the Cartesian plane, we look at the x-axis and the positive x-axis, the negative x-axis, the y-axis. We look at if you're going to your left, you're actually decreasing in steps on the y-axis. If you're going to the right, you're increasing. If you go up, you're increasing on the y-axis. If you go down, you're decreasing on the y-axis. We say that here is the origin. That's where all the points start. And we also look at how we actually plot the points on the Cartesian plane, what unit or what representation on the x-axis. How do we do that? We look at those things. We look at what happens when you have 0, 0 as coordinates. We look at when one of them is 0 and one is another number. We looked at those. So we look at many things. And so we'll be continuing on Cartesian plane and the whole concept of constructing and plotting graphs. I hope this video will be of so much use for you. You will actually use this video to do many things as relates to graphing and representation of points and coordinates and so on. See you next time.